Okay, so to start, we have plastic sheets that are set up so that you can work next to each other if you really need to. I don't think we will need to do any of that soon, but it may become an issue, so we went ahead and put those up to begin with. So this section over here is where we have experiment 2 and experiment 6. So we're not doing those at the same time because they share the same apparatus, but we will be doing those separately. And over here we have our fin problem, which I believe is experiment 8. Down on this side of the lab, back behind that complicated old senior design project, I believe, we have experiment 7, which works with insulation. And then back around here we have our stuff for our natural convection experiments, and that is 11 and 12, I think. Those numbers may not all be accurate, but they're in your lab manual, and they're pretty straightforward. Okay, this is our apparatus for experiment 2. So in this experiment, we are measuring the thermal conductivity of a metal. So that metal is inside here. So as you see, we have a little sample. I have not decided yet if we will switch out samples or not, just because that's a lot of stuff you have to touch. But I will be figuring that out with Dr. Headley soon, and once you get to lab, you'll know. So these are thermocouples, so they each will measure the temperature at a point. So you will be getting the temperature at each of the thermocouples as we go. You'll record those readings and then follow the analysis procedure in your lab manual to find the conductivity of the metal, and then you will compare that to stuff you find online to see what metal you think it is. So how you get those temperatures is we have this little thermometer tab, and so with that you will turn it to be the different thermocouples. So this, I just turned it on, it's not at steady state, so it's roughly all the same temperature. The hot water's not on there either. So you'll just turn this knob to go 1 through 6 to get your temperature readings, and then you'll also need to record the power that's going in. So just write down however many watts I have it set to when you come in, and that should be all you need for experiment 2. When you come into lab in person, I will be here, so you can ask questions about that. Okay, over here we have our fin problem set up. So we have a water heater that is putting hot water through this sink that is currently off but will be on for your lab, and is getting hot water into the ends of the fin to heat them. So we use this as an infinite fin analysis, I think is the word. I'm sure all of y'all remember that from your heat transfer class. So we have 3 different fins, but one of the knobs at the end is broken for this first guy. So we will not be doing that. Also, do not touch these. It's off right now, but it will be on for you and it will probably be hot. So we have knobs. This one's the broken one. And these 2 are for these 2 fins. So when you come in, you need to record the distance between each of these. So these are all thermocouples, and that's what you will be taking your reading at. They, I believe, are all lined up, so you can just measure them for 1 and you'll be good. But just get the distance from pretty much using this one right in here as 0, and then from there you'll record up. You'll also need to measure the diameter of this. We don't have calipers, so I don't really know the best way to do that. But we will have rulers in if you want to try that, and I may be able to sneak some calipers from home for us to be able to get that. So when you are measuring your temperature, you will turn your knob to 1, and that will give you the first reading. So there we go, and the hot water's not in, so these are not accurate readings. So you'll just turn the knob for each of the 10 thermocouples along the fin, just get recordings for that. But do make sure that the rest of the knobs are set to off. If you have two of them on at the same time, the readings get really weird. So just be sure that you do that, and it should all go smoothly. The analysis is the more difficult part for this. The actual temperature data taking isn't too bad, so we shouldn't be in here for too long today. So once again, welcome to Heat Transfer Lab. I'm excited for this semester. I'm excited to actually get to see people on campus, even if you don't get to see my mouth. But once again, just remember to bring a mask for lab, and that we will be keeping our social distance from each other. So you will likely do all of the data recording on your own, and then your lab group will just use one person's data when you do the analysis together. Because we want all of y'all to be able to see what you're doing when you're writing your group report. So let me know if you have any questions, and I look forward to seeing y'all.